All right. Hello, everyone. Thanks for being here. I know some of you from classes and from seeing you around. I'm the interim director of the Center for Data Science, and I'd like to thank you for coming. Well, thank you first for having been here in the first place and pioneering data science studies. We work very hard to develop the curriculum in the master's, in the PhD, and this would be impossible with you guys, and it's really been a pleasure educating you and you educating us also in the needs that students have nowadays for data science. We are really committed to building an alumni network and to remaining connected to you guys, because we think there's a lot of value for us, for our current students, but also for you. So we really look forward to working together with you. And I also want to thank our wonderful administrative team for setting this up, because I really think it's really important. It's very important that we grow as a community with you guys, the current students, the faculty, and we look forward to doing it. Thank you very much.
Cool. I'm just going to move that. I'll just step around the. Yeah. Cool. Yeah. Okay, cool. Thank you for being here today. Hi, my name is Umang Bhatt. I am a faculty fellow that just started here at CDS. I'm also affiliated with a couple other places. I would love to tell you a little bit about the work that we're doing here. I'll try to keep it as brief as possible, but also hopefully it's informative for you guys to get a sense of the style of work we're doing. So with that being said, I've kept this actually quite high level. This is a version of a talk that I'd given at the House of Lords earlier this summer. So it's at a level that hopefully super accessible, but sufficiently interesting. So predominantly a lot of our work covers what we call algorithmic transparency. And I like to start by zooming out and thinking a little bit more clearly about the types of systems we're building and the ways in which we're deploying them. Many times when we're studying data science and machine learning, we might start by thinking about a machine learning model that we have access to. And that machine learning model is going to interact with lots of different stakeholders in the real world, and there's going to be this constant interplay back and forth between these two individuals. For all intents and purposes of my research, we call this a human-machine team, trying to facilitate human-machine collaboration in a way that is sensible and other people can understand how the human and machine ought to work together. Predominantly, a lot of my PhD research kind of covered this top arrow, really thinking more clearly about what can we communicate to stakeholders about what we know about machine learning models in a way that's useful for them. So we like to refer to this as transparency. There's lots of principles at organizations and even technical methods that are developed for providing explanations for machine learning systems. The way I like to define transparency for our research is any type of relevant information that you can have about a machine learning model. Now, this is super vague, and it's vague on purpose, because this permits us to get access to lots of different types of transparency and lots of different mechanisms and pieces of information we can provide people with. So I'll break this down a little more. We like to consider two different types of transparency. I think by that definition that I've just provided, a prediction technically is a piece of relevant information about how a model works. But there are two large categories that we think about. The first is procedural transparency, which I like to think about as the socio-technical ecosystem where a model lives. Right? Does anybody have a sense of things that might have to do with the model, but aren't necessarily some function of the model? Any thoughts on what would be considered socio-technical? Just out of curiosity. No wrong answers. Yeah, please. Type of inputs. Okay, that's a great one. What could be fed into a system? Any others? It's a piece of relevant information about how the system works. It's very vague, but it's not necessarily some function of the model itself. Yeah? The data it's been trained on. That's a good one. But by the definition that it being part of the socio-technical ecosystem, this actually the model depends on that information. Any other thoughts? Interesting. Yeah, definitely. These kinds of like socio-technical pieces of information kind of cover a couple things. So one of them could actually just be disclosure, the fact that maybe you only have access to 50 queries for the day, right? You see this all the time when you start to interact with the system. You sign like some version of terms and conditions. There's a ton of research that goes into this, but drawing the guardrails of the research that we actually do. So I'm telling you kind of what's not in the line of work that we do. So disclosure, documentation, which kind of would cover the data that the system's trained on, what inputs can be fed into the system. I mean, in some sense, inference doesn't depend on this, right? But it's a way of documenting and providing a socio-technical infrastructure around the models such that we can communicate to people how these things work. Certification is something I'm super excited about. It's kind of like an Underwriter Labs equivalent of stamping that the system performs with this type of precision, and this is the kind of set of metrics that are permissible for this system. And technically code, by definition, is a socio-technical piece of information that you can provide to people. Now, that might not be transparency for most people, but again, it does count by the definition I've provided here. And on the other hand, we have this side of algorithmic transparency, which would be the other end of the spectrum. So prediction, perhaps even explainability, uncertainty, these are things that we necessarily work on. So what types of systems can you explain to me why your prediction, you said that this is a dog, not a cat? Can you explain to me how confident you are that this, in your dog classification, as it were? Right? So these are pieces of information that are some function of the system itself, some function of the prediction itself. So predominantly a lot of our work, we study algorithmic transparency, not the former. There's a lot of really good, smart, fun people that we know that study procedural transparency. And a lot of our work to date has been on what I like to call explainability. So if we wanted to define that more precisely, we might call that some sort of insight into how the model behaves on particular data points. So we'd run this study a couple of years ago with an organization called the Partnership on AI, which is a global nonprofit that brings together civil societies, academia, governments, and corporations to kind of think about how can we build AI to benefit the people in society. It's a lofty mission, but precisely what I'd study with them is how are people actually using some of the explainability and interpretability tools that are popular. And if we wanted to study this, we run like these semi-structured interviews with a bunch of organizations. Think about like the execs of major tech companies, heads of civil societies, heads of folks in government. And I'll just share the findings with you. And if you're interested, I'm happy to talk about it. You guys can shoot me an email. Explainability is predominantly used for debugging, which is this really weird internal finding that like the notion of an explanation feels really good, but in some sense, the tools that we've built to date aren't really they don't let end users interact with the model in a new and sensible way. In some sense, our pursuit of explanation hasn't necessarily seen the light of day. A couple other things, the definitions and goals of explainability within organizations aren't necessarily clearly defined. So I know that many of you may work in industry and you might find that there are calls for transparency and calls for explainability, especially as we start to use larger systems, and especially as we've seen in the last few weeks and months, and people talking about generative AI or the abhorrent Gen AI term that people try to use. It just doesn't make sense. But in some sense, we don't have a clear sense of what do we want to explain to whom and why. And then there are obviously a bunch of technical limitations. So as I was saying, I'm keeping this really high level. There's lots of actually good, interesting content that we can discuss here. But I kind of want to zoom out for a second and think about this idea of taking the model to the stakeholder and providing them with explainability along the way. One of the things we can find is that you can quickly manipulate the explanation to tell you what you want to hear, such that you start to use these predictions in your decision-making tasks. Specifically, I can manipulate it and I can induce what we call over-reliance. Right? I can kind of convince you. Anybody know about the Xerox experiment that happened in the psych department, I think at Stanford in the 80s? It's a very fun experiment. They lined up a bunch of people standing in line to make a copy, and then someone gets in the back of the line, and you just basically tap the person in front of you and say, I'd like to make a copy, can I cut you? And that explanation is sufficient to get to the front of the line, right? And it's like this simple manipulation that is like ridiculous, right? Like, I mean, oh my gosh, obviously all of us are waiting for a copy. And it kind of convinces us that we have to be very careful when we're trying to craft and provide people with these forms of transparency. So I think I might just close with this interesting fact that when you're thinking about providing these systems to people, you might induce different types of reliance in individuals. On one end of the spectrum, the person you're providing the prediction with might kind of loaf. This is a term in organizational behavior, which is that I will just adhere to everything you tell me. Right? I'm not going to listen to my own opinion. I'm just going to do exactly what you tell me. You kind of have this theoretical other end of the spectrum, which we call opposition. This is like your old Luddites back in the day would have just like not listened to the system and kind of literally done the opposite or adhered at all, right? And I think that there's a lot of interesting work on what is known as algorithmic appreciation, where you tend to use the system more often than you ought to, right? And then you have this idea of algorithmic aversion, which is that you tend to use the system less often than is good for you. So in our work, we've kind of thought of appreciation as a form of overtrust, aversion as a form of distrust, but you need a really healthy middle ground, right? And we've come up with a term called algorithmic vigilance. It's when I'm being sensible, using common sense, and thinking about when is it good for me to use this system. But the one thing I would like to leave you guys with is that we have a lot of people that are worried about people over-appreciating, right? Kind of like taught that all the time. Oh my gosh, everybody's going to start using ChatGPT and it's going to become so bad, right? That's not actually that big of a problem. Right? We can fix that. That's a technical problem. This is a problem because we know that people are not very great at doing tasks by themselves, right? We know that we have lots of mistakes that we come across, and we know that these systems can be quite precise. So what mechanisms do we have in place to combat aversion? None. Right? How can we start to kind of build affordances and build systems where people don't avert? It's rather worrisome that aversion is becoming more common than appreciation. So I'd leave you guys with that in your work. It's like my one takeaway is that algorithmic transparency is good, but it's worrisome if it can lead to aversion. The second takeaway, I'll just kind of jump through. Do I have time or no? Yeah? Okay, I'll just keep going. Should I keep going? Okay, cool, I'll keep going. So that yeah, sure, got it, I got it. So on the back end, I guess, to complete a human-machine team, you need to come backwards, right? You need to go back from the stakeholder to the model. But the issue is that what lives on this arrow is so nebulous, right? Values, expectations, preferences. Like, come on, like, we studied math, a lot of us, right? I mean, this is hard. This makes no sense, right? But how can we do a better job about being clear about how a stakeholder, what type of information a stakeholder would want to provide into a system and how we incorporate it? So uncertainty is actually a really interesting mechanism for actually doing this, right? A stakeholder might be uncertain about making decisions, and one of the things that we've started to champion is this idea of appropriate access. So that means that if you have two different individuals, Alice and Bob, you might provide Alice with access to ChatGPT all the time, but you might only provide it to Bob 50% of the time. And this might be for various reasons. This might be that Bob's is a fields medal, and he doesn't necessarily need ChatGPT to do elementary level proofs, but Alice is a fifth grader. She'd love to do proofs using ChatGPT, right? So there's an interesting balance of if we start thinking more clearly about when we're actually providing people with these systems. And there's various reasons and things reasons you do this. One, it's cost saving, right? Like, you don't need to give it to Bob all the time. There's, again, the expertise, as I mentioned, or maybe there's some policies that are in place. You can't trade certain stocks if you haven't taken certain exams, right? You can't, it's basically the same thing. We have these affordances we've built for making sure that the right people are using these right forms of decision support at the right time. So my second takeaway to you would be that the appropriate use of AI systems can actually be learned. So we have a bunch of work actually learning these policies from Alice and Bob on the fly, which if you're excited about, it's actually quite fun. So, in sum, I think thinking about this idea of a human-machine team is at like the core of data science. On the top, I talked to you a little bit about the types of work we've done on transparency. On the bottom, there's a lot of preference solicitation and access work that we're basically thinking about how to get access to these forms of machine learning. I love to work with lots of collaborators in lots of different fields, which I think is really important, both across law, design, philosophy, and obviously CS. And I'll take any questions if I have time. Thank you. Yeah. I guess we have time for one question or zero questions? I don't know. Or none. A single question, sure, if you have any. No worries if not. Sure. Yeah, whoever. Yeah. So a lot of what shows up there is that you can exploit that, right? Because if I know what you want to hear, I just tell you what you want to hear. So there's this like a line of work that people call like ethics washing, right? Where it's like, okay, I know what you want to hear, so I'll just tell you what you want to hear. Like we've done a bunch of work where we tried to like, if I knew that you were going to use explanations downstream to determine the fairness of a model, I can start building explanation methods and building attacks, like adversarial style attacks, that'll basically make it look like my model is fair just from the explanation, right? So you've like ethics wash your explanation, be like, oh, of course it's not unfair. Like, look, the sensitive attribute is not used at all. We're not using race at all to make these decisions. It's pretty easy to do, right? And that's scary, but it's also something to be aware of, right? As someone who's a data scientist, like, you know that these confirmation biases exist and you can exploit them. Obviously you shouldn't, but you should know that it's obviously very possible. Yeah, cool. Do you have a question? Yeah, go for it. Yeah. Sure. Yeah. Yeah, sure. Yeah, basically putting up safety guardrails. And I think that's why that last point around access is important. So thinking about access as a problem that can be learned, right? Where I'm thinking about when do you have access to this system? Like, are you asking, like, the reinforcement learning with human feedback work that OpenAI has been championing for, by the way, 8 years. Like, it's not new at all. This line of work is basically trying to put up these guardrails. I'll leave you guys with one anecdote, which just gives you a sense of how nefarious some of these things can be. One thing that I had dinner years ago with this professor of poetry, and 2 years ago, and she is in a bunch of jihadist group chats for the Taliban. She studies poetry and particularly how music is used by terrorist organizations to rally the troops, and they are worried about the infinite generation of content that will basically be propaganda. Because I can get an infinite number of poems. One might work. But if I can get an infinite number of them, there is a serious problem. So how do we start to think about even putting up guardrails, maybe via regulation, which is why a lot of our work is with regulators, to think about, okay, maybe we should ban the usage of these systems in certain areas or for certain types of uses. So it's a tough question. I don't have a good answer, but that kind of story keeps me up at night because I'm like, I actually don't have a solution to this, but I know it's a problem. So thank you so much for your time today. Cheers.